So now we'll be looking at some past questions to see how to apply some of the concepts that we've learned. So in this first question, we are told that if three unbiased coins are tossed, find the probability that they are all heads. Now to know the total number of outcomes, so the total outcomes, I told you that when you are dealing with coins, to find the total number of outcomes, it will just be 2 raised per n, where n represents the number of coins that you are tossing. In this case, you are tossing 3 coins, so you're going to have 2 raised per 3, so you are going to have 8 outcomes. So when you toss 3 coins, you get 8 outcomes, and to list out those outcomes, you can either get head, head, head for the 3 coins that you tossed, or you can get head, head, tail, or it can turn out to be head, tail, head, or tail, head, head, or head, tail, tail, or tail, head, tail, or tail, tail, head, or finally tail, tail, tail. Now if you count these various possibilities, you see that there are 8 in number: 1, 2, 3, 4, 5, 6, 7, 8. So the question asks us to find a probability that the 3 of those coins will show heads. So now if you remember, our probability for head will be equals to what? The number of head over the total outcome. Now out of our possible outcomes, how many of them show up as 3 heads? You can see that only one of them show up as 3 heads. So our number of heads in this case, or 3 heads showing, is just 1, and the total possible outcomes is 8. So our probability of having all 3 heads show up is 1 over 8, and that makes A the correct option. In this next question, we are told that a container has 30 gold medals, 22 silver medals, and 18 bronze medals. If one medal is selected from the container, what is the probability that it is not a gold medal? Now if you recall, this is a classic question that has to do with complement of events. So now the probability of not gold is the same thing as finding the probability of gold prime, and we see that probability of gold prime is equals to 1 minus probability of having gold. So now what is the probability of having gold? Now probability of getting gold will be equals to the total number of gold medals that are there over the total number of medals. So what is total number of gold medals? You have 3. Now what is total number, or 30 rather, and what is the total number of medals? That will be 30 plus 22 plus 18, and that gives you 70. So you have 30 over 70, and that is equals to 3 over 7. So the probability of gold complement, which is written as probability of not gold, will be 1 minus 3 over 7. And what would that be? That will give you 4 over 7, and that makes A also the correct option. Now to solve this question, I'm going to use another means or another logic to go through it. So now that we're told that what is the probability that it is not a gold medal, what can we think of? Now if it is not gold medal, what does it mean? It means that the one medal that I draw can either be silver medal or bronze medal. So if it's either silver or bronze medal, then it is not a gold medal. So if I do this, probability of having a silver medal or probability of having a bronze medal, and I sum it together, I should get the same answer. Now probability of having a silver medal is supposed to be S, because the number of silver medals that are there, 22, over total number of medals, which I've calculated to be 70, and the probability of getting bronze medal will be what? 18 bronze medal over 70. So the probability of getting a silver medal or a bronze medal is probability of getting a silver plus probability of getting a bronze, which will be equals to what? 22 over 70 plus 18 over 70, and that is 40 over 70, which is equals to 4 over 7. So as you can see, we arrived at the same answer. So the important thing to know there is that in this case we made use of the idea of complement. So the probability of not having a good is equals to 1 minus the probability of having a good medal. While in the second instance, if you are not going to pick a gold medal, then it means must either pick a silver medal or a bronze medal, and we solve it, and we saw that we arrived at the same answer in both cases, just that the first approach was quicker. Let's take a look at this third example. And I told that a basket containing 9 apples, 8 bananas and 7 oranges. A fruit is picked from the basket. Find the probability that it is neither an orange nor an apple nor orange. So if you pick out a fruit and you have a basket that made out of 9 apples, 8 bananas and 7 oranges, and now you have to pick out a fruit, and I told that what is the probability of picking a fruit that is neither an apple nor an orange? That means the fruit you pick should not be an apple, and at the same time it should not be an orange. If it is not an apple and an orange, then what would it be? Then definitely it will be a banana. So this question is just a glorified way of saying what is the probability of picking up a banana. So you just have to know how to interpret your question. So that will be equals to what? Number of bananas over total fruits in the basket. So now what is the number of banana in the basket? You have 8. Now what is the total number of fruits? Total number of fruits will be 9 plus 8 plus 7, and that gives us 24. So you have 8 over 24, and when you divide you get what? 1 over 3. So the correct option to this question is option D. In the next question, we are told that, or are asked that a bag contains 5 black, 4 white and X red. So you have a bag that contains 5 black marbles, 4 white marbles and X red marbles. If the probability of picking a red marble is 2 over 5, find the value of X. Now we know that the probability of picking a red marble equals to what? Number of red marbles over what? Total number of marbles. Now what is the total number of marbles? So the total number of marbles will be equals to what? Number of black 5 plus number of white 4 plus number of red, which we are given as X, plus X. So that will give me what? 9 plus X. Now I'm told that the probability, the value is what? 2 over 5. So now the number of red marbles is what? X, and that is what I'm looking for, over the total number of marbles will be what? 9 plus X is equals to, we are given the probability value to be what? 2 over 5. So when we cross multiply, we get 5x is equals to 2 into bracket 9 plus x. So we have 5x to be equals to 18 plus 2x. So that becomes 5x minus 2x is equals to 18. So you have 3x is equals to 18, and when you divide both sides by 3, you get a value of x to be equals to 6. So when you have 6, so the number of red marbles is 6. And to test out if your answer is correct, if we divide the number of red marbles by the total number of marbles here, you are supposed to get 2 over 5. So to test it, the number of red marbles will be what? 6, and the total number of marbles will be 9 plus 5 plus 6, which will be 15. And when you divide both sides by 3, you get 2 over 5, which is what you are given in the question. So we know that definitely the value of x is 6. So that makes D the correct option. In the next question now, I told that the result of rolling a fair dice 150 times is as summarized in the table below. But now you can see that this is an example of an experimental probability, because we are trying to carry out an experiment in which we throw a fair die 150 times. So now the question now asks us to find the probability of obtaining a 5. So now we know that the probability of obtaining a 5 will be equals to what? The number of 5s that occur, or the frequency of 5 over the total frequency. Now we try to read out. We know that the total frequency or the total number of throws is what? 150. So we know that our total frequency is 150. But how about the total number of times that 5 appears? So the number 5 appears 2x time. So we know that probability of 5 appearing will be what? 2x over 150. But now we have to figure out what the value of x is. And if you remember our discussion on the representation of data, we know that the sum of all our frequencies must be equals to the total number of throws, which is 150. So I can write out that 12 plus 18 plus x plus 30 plus 2x plus 45 must be equals to 150. Now when you collect like times, you have 3x plus 105 to be equals to 150. So you have 3x to be equals to 150 minus 105, which is 45. So x will be equals to what? 45 over 3. And what would that give me? That gives me a value of 15. So if I substitute the value of 15 here, so my probability of having a 5 will be equals to what? 2 times 15 over 150. Now 2 times 50 is what? So I have 30 over 150. And when you simplify that, you get what? 1 over 5. And that makes B the correct option to this question. In this next question now, we are told that the table above shows the number of pupils in each age group in a class. What is the probability that the pupil choosing at random is at least 11 years old? So now what does this word here means? At least. When you say something is at least, that means it can be that particular value or greater than that value. So in this case now, the probability of having at least 11 will include probability of having 11 and other ages that are greater than 11. So in this case now, that will be equals to probability of what? At least 11 years old now will be equals to what? Probability of having either 11 years old or probability of having 12 years old, because you know that at least means that particular number and any other age that is above that minimum. So what would that be? That would be probability of 11, and we know that our all is same as what? Plus probability of 12. So now we can easily find out the probability of having age of 11. That is pretty straightforward. So this is another experimental probability. So we have to calculate the total number of pupils. So when we had 6 plus 27 plus 7, we get what? We get 40. So we know that the probability of picking up a student of age 11, because of the total number of students that are aged 11, which is 27, over the total number of pupils, which is 40. The same logic applies. So the probability of picking a student that is 12 years old will be what? Total number of students that are 12, which is 7, over total number of students, which is 40. So what does this become? Probability of 11 we are found to be 27 over 40, and this becomes plus 7 over 40, and that is equals to what? 34 over 40. And when you divide both sides, numerator and denominator, by 2, you get 17 over 20 to the lowest term. So what does that mean? It means that B is the correct option to this question. So to recap, we are told to find the probability that at least a student chosen is 11 years old. And I explained that at least means that the student can either be 11 years old or any other age greater than 11 years old. And in that case, that will include both students that are 11 years old and 12 years old. So we calculated the probability of having a student that is to be 11, which is 27 over 40, and the probability of getting a student that is 12 years old, which is 7 over 40. Then we sum them up together and we simplify to get option B. Now let's move on to this next question. I told that the table above represents the outcome of throwing a die 100 times. This is also an experimental probability. So what is the probability of obtaining at least 4? So you see this keyword again, at least 4, a 4. So what does it mean? It means that you should find the probability of having 4 or anything greater. So you have probability of at least 4 to be equals to probability of having 4, or you can have a 5 in this case, or you can have a 6 in this case, since it will include both showing the 4, 5 and 6, 4 and any other values that are greater than 4. So we explained that having or is the same thing as addition. So that is probability of 4 plus probability of having a 5 plus the probability of having a 6. So now, when you sum up all these frequencies together, it will be equals to the number of truths, which is equals to 100. So we can easily calculate the probability of getting a 4. So how many times does a 4 appear? A 4 appears 16 times. And how many truths was done? 100 truths. The probability of picking up a 4 is what? 16 over 100. How about the probability of picking up a 5? How many times did a 5 appear? A 5 appeared 10 times, and the total number is 100. And finally, the probability of picking up a 6 is what? 14. 6 appeared 14 times over 100. So we can easily sum it up. So probability of a 4 is 16 over 100 plus 10 over 100 and plus 14 over 100. And that will give you what? 40 over 100. Which when you simplify will give you 2 over 5. So that makes D the correct option to this question. So to recap again, because we are told to find the probability of obtaining at least a 4, it will include all values that range from 4 and above. So probability of having a 4, or probability of having a 5, or probability of having a 6, which you have to add. And to get it individual probabilities, we've divided the frequency in which they occurred by the total number of times that the die was truth, which is 100. And when we simplified, we got 2 over 5, which is D. Let's move on to the next question. And here we are told that the table above shows the distribution of marks of students in a test. Find the probability of passing if the pass mark is 5. So this is also a very simple question that just requires you to apply simple logic. So now, we are told to figure out what the probability of passing is. So probability of passing. Now, what is the probability of passing? Now, we are told that the pass mark is 5. So what does it mean for the pass mark to be 5? What it means is that if you get any score from 5 and above, let me indicate it, from 5 and above, that means what? You passed the test. So probability of passing in this case will include the probability of getting either you scored a 5 plus the probability if you scored a 6 plus the probability of if you scored a 7 plus the probability of if you scored a 8 plus probability of if you scored a 9, because all these conditions here fulfill passing because it's greater than or equals to 5, and we both add because we have or as I've explained in the previous example. So we just have to add them up together. So now to find the probability of each of these events, we know that the probability is equals to the number of favorable outcome over total number of outcome over total outcome. Now to find the total outcome, what do we have to do? We just need to sum up all the number of students that took the course, or the total frequency. And when we sum up these frequencies over here, what do we get? 3 plus 4 plus 1 plus 0 plus 4 plus 5 plus 2 plus 1 gives us what? Gives us 20. So the probability of picking up a 5 will be equal to the frequency of 5, which is 0, over the total number of students, which is 20. Probability of getting a 6, or scoring a 6 will be what? 4 over 20. Probability of a 7 will be what? 5 over 20. Probability of 8, frequency is 2, so you have 2 over 20. And finally, the probability of getting 9, you have 1, should be what? 1 over 20. So what would that give you? When you sum all this together, you get what? 12 over 20. And when you simplify, what does that simplify to give you? You get what? 3 over 5. So that means the probability of passing this course means the probability of getting either 5 or 6 or 7 or 8 or 9. And when we evaluated that, we got 3 over 5. So the probability of passing is 3 over 5. And that makes A the correct option to this question. Now let's move on to another question that has to do with independent events now. So the probability that the student passes a physics test is 2/3. So we know that the probability of passing, let me represent passing as P, is equals to what? 2/3. Now if it takes 3 tests, so the student now takes 3 tests, 3 physics tests to be precise, what is the probability that he passes 2 of the tests? So what does it mean if he passes 2 of the tests? It means that what? He passes 2 of the tests while he fails the third one. So they're telling us to find the probability of passing 2 of the tests and failing the third one. Failing, I'm going to represent as F. So now we know that probability of passing plus probability of failing must be equals to 1. As I've explained, the sum of probabilities for mutually exclusive events must be equals to 1. So now the probability of failing now will just be equals to what? 1 minus probability of passing, which is what? 1 minus 2/3, which is what? 1/3. So now what is the probability of passing the first test and passing the second test and now failing the third test? So what would that give you? That is pretty straightforward. And what would that be? So that would be what? Probability of passing the first 2 tests will be what? Probability of passing, we said, is what? So that would be probability of passing times probability of passing times probability of what? Failing. So what is the probability of passing? The probability of passing is what? 2/3 times 2/3, and their independent events, and probability of failing is what? 1/3. And when you do that together, what do you get? You get what? 2 times 2, 4. You get 4/27. So the probability of passing 2 out of the 3 tests that it takes is what? 4/27, which is option C. Now let's move on to the last question. And in this question, we are told that in a class of 60 students, 30 offer physics and 40 offer chemistry. If a student is picked at random from the class, what is the probability that the student offers both physics and chemistry? So this is a classical mixture of both set and probability. I'm going to try to draw out this set. And if you don't understand sets, you can look up the section on set to understand what I'm doing here. So we are told that the universal strength or the universal number of students is what? 60. And we have 2 subjects. So that people that take physics is 30, and number of students that take chemistry is 14. So now if I say X should represent the number of students that take both subjects, then the number of students that take only chemistry will be 40 minus X, and number of students that take only physics should be what? 30 minus X. So to find X, I know that the total number of students must be equals to what? 60. So people that take only physics is what? So 30 minus X, then people that take both plus X, and people that take only chemistry, which is what? 40 minus X, must be equals to 60. So what would that give me? So here I have what? Minus X plus 70 is equals to 60. So I have my minus X is equals to minus 10. So my X value is equals to what? 10. So that means the number of students that take both subjects is 10. So if I substitute it here, the number of students that take only physics will be 30 minus 10, which is 20. And the number of people that take only chemistry will be 40 minus X, or 40 minus 10, which is 30. Now I'm going to solve this using 2 approach. So the first method now, the question asked me to find the probability of students that offers both subjects, which is 10. So now I found the number of people that offer, so the probability of both will be equal to what? Number of both subjects over total students. So now how many students are taking both subjects? We've calculated that to be 10 over how many students are taking, how many students do we have altogether? We have 60 students, and when you simplify, you get 1/6, which makes option D the correct option. But now to apply our idea on using independent events. So probability of taking both subjects, physics and chemistry, is same thing as having probability of physics and chemistry. I know that when you have and, you have to multiply, so that will be probability of taking physics times probability of taking chemistry. Now what is the probability of taking physics now? We have figured out that the number of students taking physics is 20. So probability of taking physics is what? 20/30. Sorry, 20/60 over total number of students, and that will give me what? And that is what? 1/3. While the probability of taking chemistry, number of students taking chemistry only is 30. So you have 30/60, and that is equals to what? 1/2. So the probability of taking physics and chemistry equals to 1/3 times 1/2, and we still end up at the same answer, which is 1/6. So as you can see, whatever method you choose to apply, we end up at the same answer. So there is no one particular fixed way to tackle probability questions. So it's really important that you understand the underlying principles so you can know the shortest and the quickest method to employ. And as you will see by now, most of the questions that do come out in JAMB are not as challenging as some of the examples we solved. So if you are able to grasp the underlying concepts, then attempting JAMB questions should not be a difficulty. So that pretty much sums up our discussion on probability, and I want you now to go through the exercises and try to tackle the questions that are there. And you can also look up your past questions for additional questions. And if you have any challenge, do not forget to make use of the forum where you can connect with other students and learn together. So that'll be all. Bye.